My name is Shunathan Nalajiri from WWF Thailand. You can call me Sue. Let me introduce the Asian Pollinator Initiative Alliance, or we call as abbreviation as APIA. So welcome everyone. Today we're gonna talk about pesticides and bee. Um, this this webinar we have set for this time for the fifth time, and it support the supporting organization are Invisible of Southeast Asia, WWF Thailand, Go Organic Peace Organization, EarthNet Foundation, Biothai Foundation, and group of volunteers. So today we have speaker. Sorry. So the agenda today is introduction for 5 minutes, and Eugene, our speaker, gonna share his knowledge about pesticide and bee for 40 minutes, and then we have Q&A that you can type the question in the chat box, and we can discuss for 25 minutes, and then we're gonna official closing for the webinar about around 3:30 in Bangkok time. So let me talk about Eric Eugene. I'm sorry, Eric Guerin. He is the French biologist specialized in Southeast Asia native bee conservation and sustainable beekeeping. He has been in Cambodia since 2008, and he has been working closely with the honey hunter and small-scale beekeeping throughout Southeast Asia. So let's talk about the rule or housekeeping of this webinar a bit. So please kindly ensure your microphone is muted and use the chat function to send your comment and the question. So everyone, please say hello to other audience in the chat by sharing your name, your organization, or your email contact, where you come from. So this session is going to be English speaking and Thai translator. So สำหรับพี่ๆที่เป็นผู้เข้าร่วมภาษาไทยนะคะสามารถกดที่ปุ่ม translation เพื่อเลือกฟังภาษาไทยได้นะคะ So let me talk about APIA a bit. It's initiative from the last year, early 2020. And the objective, we want to connect the like-minded people on organization for the conserve and raise awareness about pollinator protection, as well as for the sharing knowledge and resources. So as I mentioned before, the co-founder or NGO foundation is WWF, Thailand, Invisible Southeast Asia, Biothai, and Go Organic Peace International. This is the event that we have set since 2019, and then we have set offline and online event and the trip, and right now we have 5 webinars in this year because since the COVID situation. So and I want to introduce you all the APIA Facebook group that you can join us, and we're gonna update about the event, webinar, and trip, and whatever is gonna happen in the future, and we share the knowledge about pollinator and beekeeping here. So let me throw to คุณกิ่งกร Thai Pan. Please mute your microphone พี่กิ่งก่อน
Sorry. สวัสดีค่ะ So I think I'm going to be also the facilitator for this talk, but let me start with the introduction to Taipan and Biothai first in a very brief speak. Taipan is a network founded as a collaborative together with Alternative Agriculture Network, civil society, NGO, and also academics who have a huge concern on the impacts of pesticides on food production and agricultural system. We started since 2011, and Biothai has played as the organizer and secretary to this network. So we started with the issues that we calling for ban for substances. Chemical substances is very high toxic, namely carbofuran, metromyl, EPN, and diphotophos. Kun Bokchon so here with me, and she could answer technical problem question as come up in the talk. Move from that four substances that we call for banning since the very beginning of Taipan in 2011. So we moved to another toxic chemical used in our food system, namely paraquat, chlorpyrifos, and glyphosate. It's been a long fight, and we finally successfully can ban it in last year. With two paraquat and chlorpyrifos was announced to ban, but not fully affected in terms of practicing, I think. And also glyphosate is not banned yet, but it's on the level of limited use, but still ongoing that we still calling for pay consideration in banning it. And also we have done quite a lot of survey in terms of kind of market surveillance survey, taking samples from markets, fruits and vegetables for almost 8 years already. And we found that almost 50% is contaminated. So that is the contamination of pesticide in our food. But still we have quite little knowledge on what is the effect on or impact on the populations in Thailand and how it's affect to the pollinations in food production system. So we joined APIA group and think that we can learn more. And I'm really happy that we are having this discussion today. Thank you for Eric to accept to talk, and we still going on talking next time also. So this is the 5th talk, and next talk will be next month. But now we look at the experience and knowledge on what Eric's have been doing studies since 2008 in Cambodia and throughout Southeast Asia. So I would like to give the floor back to Sue, and also maybe I could invite directly that the microphone is yours, Eric. And after Eric talk, we will have a question and answer session or sharing more information. And anyone could feel free to write the question or observation through chat. Thank you. The floor is yours, Eric, I think.
Okay, so I will share my screen.
Next for the Eric for share his knowledge.
Okay. Sorry. Okay. Okay. So good afternoon, everybody, and thank you. Can you hear me?
Can you volume up a bit?
Oh, is it okay like this?
Yeah, it's great.
Oh, okay, sorry. Okay, so good afternoon, everybody, and thank you to give me the opportunity to share some work that I did It's just a personal research that I conducted in 2019 with the aim of raising awareness of Cambodian government representatives and some NGOs working on agroecology in Cambodia. So before starting my presentation, I would like to specify that I'm not a pesticide specialist. As it was previously mentioned, my main focus is on Asian native honeybees conservation and small-scale beekeeping, like sustainable beekeeping. So just a brief introduction of native bees in native honeybees in Southeast Asia. So among the 9 honeybee species known worldwide, only one, the Western honeybee, Apis mellifera, is native to Europe and Africa. The 8 others are Asian. And in Cambodia, as you can see with the yellow star on the map, we have currently 5 honeybee species. 3 of these species are what we call single comb open air nesting. Their nest is made of a unique comb built in the open air. One of these species is a giant honeybee. We call it Apis dorsata, the Asian giant honeybee. So you can see workers' bees of Apis dorsata here. It's a quite large bee, about 2 centimeters in length. And that's the nest, the open air single comb nest of Apis dorsata. The 2 other single comb open air nesting species are dwarf bees. So they are the smallest bees in the world. One is red, it's called Apis florea, and the other one is black, Apis andreniformis. The 2 last honeybee species that we have in Cambodia are multiple comb cavity nesting bees. Their nest is made of multiple parallel combs built inside a cavity. And this characteristic is important because it's because of this that these 2 species are amenable for beekeeping. One of the 2 species, the eastern honeybee, Apis serrana, is native to Asia, and the other one was introduced, Apis mellifera, as the European honeybee. So let's talk a little bit about pesticide. So pesticides are substances that are meant to control pests. And they can be classified by the group of organisms they target. For example, herbicide to control weeds, fungicide for fungi, insecticide for insects, acaricide for acarians, and so on. So to the question, are pesticides a threat for bees? The answer to this question should be no. Indeed, as bees are not considered as pests for any crops, bees are not a specific target for pesticides. In other words, no pesticide has been specifically designed to control bees. Unfortunately, pesticides are not only toxic to the group of organisms they target. And it is considered that, actually most of the pesticides reach a destination other than their target species. It can be a big proportion of this pesticide that will impact other organisms. To evaluate the toxicity of a pesticide on bees, we need to answer 2 questions. How much pesticide is needed to kill bees, and how long the pesticide will remain in the environment, or how long it will can affect the bees. The answer to the first question, The answer to the first question is given by what we call the acute toxicity of a pesticide, also called the lethal dose 50 or LD50. It is a dose of pesticide that is required to kill 50% of the bees exposed to this pesticide. And the Environmental Protection Agency in the US set up a limit of 11 microgram per bees to design a pesticide as toxic for bees. So, and sorry, so one more thing important. Of course, the lower the LD50 is, the more toxic the pesticide will be. So, put in simple words, any pesticide with a LD50 lower than 11 microgram will be toxic to bees, considered as toxic to bees. The answer to the second question is given by what we call the half-life of a pesticide. It is the time required for half of the pesticide to disappear. After the first half-life, we still have 50% of the pesticide. After the second half-life, we still have 25% of the pesticide. As an illustration of the toxicity of pesticide to bees, this table shows the acute toxicity and half-life for a few pesticides. I choose 4 groups of pesticides, so herbicide, fungicide, acaricide, and insecticide. I will not go into too many details, but just broadly speaking, acaricide and insecticide are more toxic to bees than our herbicide and fungicide. So as you can see here, the acute toxicity is usually smaller than it is for herbicide and fungicide. Within the insecticide family, we also have huge differences in terms of toxicity for bees. This pesticide here, insecticide, is called fipronil, is actually 50 times more toxic to bees than beta-ciflutrine, sorry for the pronunciation, and 5,000 times more toxic to bees than DDT. We also have huge differences in terms of persistence in the environment, so the half-life. That can last between a few days for this pesticide here, up to 17 years for DDT. And fipronil, which remember was already very toxic to bees, has a half-life of 4 months. It means that this very toxic pesticide, after 8 months, we still have 25% of the pesticide is still here. So after 1 year, there will still be pesticide in the environment. So if this very toxic pesticide to bees is applied once a year, it will be present in the environment year-round. And I will talk again about this family of pesticides. This pesticide belongs to the systemic insecticide. So just remember this name. It's important for a little bit further in my presentation. So what happens when bees are exposed to several pesticides simultaneously? Actually, the toxicity of certain pesticide or insecticide can be enhanced in the presence of other pesticide, which act as synergists. We are talking about cocktail effect. For example, the fungicide with a low toxicity to bees can inhibit the detoxification system in bees and thus decreasing their capacity to eliminate the toxic insecticide. So a toxic insecticide can become even more toxic to bees if the bees is exposed to another pesticide that is even though the other pesticide has a low toxicity to bees. So how can bees get intoxicated by pesticide? Actually, there are 2 main routes of exposure. Bees can touch the pesticide. In such case, we're talking about contact exposure. They can also ingest the pesticide. In such case, we talk about oral exposure. Regarding contact exposure, bees might be intoxicated while crawling over sprayed surfaces of plants or flying across treated fields. But that's not all. Bee colonies nesting downwind up to 100 meters away can also be intoxicated by pesticide droplets or contaminated dust particles brought by winds. And there is, it's not all, still not all. Bees can also carry the pesticide to their nest, either as dust particles or droplets attached on their body. And in a nest, they will contaminate other bees or larvae just by contact. So they will by touching other bees or bee larvae, they can also contaminate them. Secondly, when forager bees feed on contaminated pollen or nectar, they may die if they ingest enough pesticide, and which can be even worse, they can just get intoxicated and share the contaminated food with other bees and larvae and even the queen, and thus intoxicates the whole colony. So I will now talk about a specific family of insecticide, which are called the systemic insecticide. This insecticide can be used as spray or coated seed. Coated seed are these beautiful seed here. They are beautiful, but very dangerous to bees. And systemic insecticide, as far as I know, are the most commonly used insecticide worldwide. So why these insecticide are so dangerous for bees? There are several reasons. The first, as they are water soluble, they are absorbed by the crop as it grows. And as a consequence, residues of pesticide will be present in all the part of the treated plants, including what is important for bees, flowers, so pollen and nectar. So when the bees feed on the plant that was treated by systemic insecticide, they ingest the insecticide because the insecticide is everywhere in the plants. Systemic insecticide pose a risk to bees, not only because of their particular mode of action that I just mentioned, but also because of their higher toxicity and longer persistence in the environment. Most neonicotinoids, neonicotinoids is one of the, most systemic insecticide are neonicotinoid. Maybe some of you know this, the name neonicotinoid better than systemic insecticide. So most neonicotinoids have a lethal dose 50 in the range of 4 nanogram per bee. So what does it mean? It means that these 4 nanograms is 3,000 times lower than the limit set up by the Environmental Protection Agency in the US for bee toxic pesticide. So another way to say it is that systemic insecticide are 3,000 times more toxic to bees than what is considered at the limit, the limit toxicity to bees. To put this in other words, 1 teaspoon of neonicotinoid is enough to kill 1.25 billion bees. This, when I read this number, it didn't make much sense to me, because when we're working with bees, we are not so much focused on individual bees because bees are social insects. What matters are the colonies. So I try to turn this into colony numbers. Usually Apis mellifera colonies count around 50,000 bees, can be more. So 1.25 billion bees are the population of 25,000 colonies of Apis mellifera. For Apis cerana, one of the native bees we have here, it will be about double, so 50,000 colonies. And if we are talking about dwarf honeybees, dwarf species, that would be 10 times more, so 250,000 colonies of Apis florea or Apis andreniformis could be killed by 1 teaspoon of neonicotinoid. But that's not all. The threat of systemic pesticide for bees is not limited to the crop plant, as only a small part of the insecticide is absorbed by the crop. The remaining is absorbed by other plants or end up in water bodies. As a result, not only the crop plant, but also the weeds and bushes that grows in or near the field treated, as well as water bodies, are contaminated by systemic insecticide. And thus, they are potentially deadly to bees. And just a small point, contamination by water should not be neglected. Bees use a lot of water. They need water like us. They need to drink, but that's not all. They also use a lot of water for the thermoregulation of their nest. So I have just one figure from Europe. One colony of Apis mellifera in Europe, so it's not so hot, consume 100 liters of water per year. So just imagine if 100 liters of water is full of systemic insecticide are also famous for their chronic effects on bees and bee colonies. Chronic effects are usually linked with exposure to sublethal doses. So doses that are not deadly to bees. So bees will get intoxicated and bring the insecticide to the colony. So sublethal doses of neonicotinoids or systemic insecticide will increase foragers' disorientation. So foragers will be less efficient to collect pollen and nectar. So they will bring less food to the colony. In addition,
ตามที่มันเคยชินเพราะฉะนั้นมันอาจจะหลงทางเพราะนั้นสารนี้ก็อาจจะทำให้ภูมิต้านทานของผึ้งเนี่ยลดลงเพราะฉะนั้นผึ้งก็จะติดโรคต่างๆได้ง่ายมากขึ้นแล้วก็เนื่องจากผึ้งก็เป็นแมลงสังคมเพราะฉะนั้นในเรื่องของ
fertility. As a result of all this, colonies feeding on honey, pollen, or water contaminated with systemic insecticide may succumb to the combined effects of chemicals and disease. Pesticides are also present in bee product. Recent studies have shown that most honeys, wax, and bee pollens worldwide are contaminated bees with pesticide. A research conducted by a university in Switzerland on about 200 samples of honey from all over the world found that 75% of honey worldwide contain neonicotinoids, and half of them were contaminated by pesticide cocktail. So most honeys contain the most dangerous pesticide for bees, and half of the honeys contain several pesticides, which is potentially more harmful to bees. The good news is that concentrations are below the maximum allowed for human consumption. So that's the good news for us. The bad news for bees is that these concentrations are alarming to bees. Half of the honey worldwide contained pesticide at concentration above toxicity limits for bees. So as we know that bees firstly produce honey for their own consumption. It means that when bees forage on contaminated flowers with pesticide, they will produce poison food and potentially deadly food to them. Not only honeys are contaminated, but also beeswax and pollen. Research found that there were more types of pesticide in honey, but the pesticide concentration were higher in pollen and beeswax. So I don't know if all the attendees are familiar with this. This is what we call a worksheet. Worksheet is very useful to beekeepers. They use these worksheets to facilitate the work of bees. So bees will go faster building the comb. Yes, bees usually on average, bees will use about 8 to 10 kilos of honey to produce 1 kilo of beeswax. So by using this worksheet, beekeepers give a good help to the bees. Unfortunately, the research found that most worksheets in Europe were contaminated by pesticide. And just this research in France in 2012 on 260 wax samples found that all except one sample were contaminated. They found 8 pesticides on average on all the samples. One sample had up to 39 different pesticides and almost 90 pesticides were found. So this is something very important. This research were conducted in Europe, but I don't think it will be so different in Asia, neither in Southeast Asia. It means that beekeepers, by using worksheets, not knowing where these worksheets are coming from, they are very likely introducing pesticide in their bee colonies. And yes, some beekeepers in Europe prefer to produce their own worksheets because they are really concerned about this. So how could pesticide be a threat for beekeeping in Cambodia? But it's the same for Southeast Asia. So mainly pesticide might impact Southeast Asian beekeeping in 2 ways. First, beekeepers may lose colonies if their colonies are killed by pesticide, but they may also lose productive but contaminated apiaries. So in Southeast Asia, several fruit trees are very good to produce honey, such as longan. I think in Thailand, you know longan very well. It's a very, very good bee plant, but it's also often highly treated by pesticide. If the pesticide contamination is too high, beekeepers may stop placing their hives in these orchids, so they will lose opportunities to produce honey. Regarding native bees, so the impact of pesticide on native bees is poorly known, but it doesn't mean that they are not impacted. They're just not monitored, and that's a big difference. There is a lot of noise about the impact of pesticide on bees, but most of this is related to domestic bees. And the reason is simple, it's because beekeepers, when they lose their hives, they complain. But nobody care and nobody complain about the native bees. So how could the native bees could be impacted? I see, let's say 2 ways. First, similarly to domestic bees, they can be killed or weakened by pesticide intoxication. When I'm talking about a weakened colony, it means that the colony may not die, but if a weakened colony will have a lower swarming rate. Swarming is a reproduction mode of honeybees. And when we're talking about, native honeybee conservation, what matters is the population, not even the colony itself. If the colony survive but cannot produce swarms, the population will decline. So this is, let's say, oh, I forgot the name, but anyway, so that's very, very important. Another way native bees could be impacted is a consequence of impact of pesticide on beekeeping. If beekeepers start to move their hives from contaminated apiaries to a natural ecosystem, their domestic bee colonies may increase, it may increase the competition for flower resources with native honeybees. I don't know exactly what is going on about this in Southeast Asia, but in my country, in France, it's already a problem. Many areas of rural area in France are highly contaminated by pesticide. And so many beekeepers are tempted
Right now, Eric has some error.
Eric's gone disappear.
So,
Hello.
hello, Eric. Okay, I think he's now reconnecting the internet, and we'll be back soon, I think.
So in this case, so we wait. I think we should wait. Oh,
Yes, he's back. Okay, Eric, can you unmute?
Yes. Okay. Let me start again.
So moving colonies into the ecosystem, natural ecosystem.
Yes.
That we are where we were.
Oh no, I should not do like this. Sorry, I have to do it. Oh yes, like this. Oh.
Please share your screen.
Yeah. Oh yeah. Yes. Sorry. I'm sorry. I'm getting lost. Okay. Let's start again. All right. Okay. I'm sorry for this. Okay. Share screen. Yes. Okay. Highlight this. And oh, but no, it's not good like this. I'm sorry. I think
The previous slide.
Is that okay, or can you see what can you see? Can you see the slide, or?
Yeah,
I see the slide with note. So you
you see the note also. I start again. I'm very sorry for this. Yes. Okay. Let's.
We were at the slide number 23.
Yes, but
23. Eric's.
Okay, but no, it's not about this. Oh, anyway, it's okay. I will continue like this. So, oh no, but now you don't have it. Oh, I'm sorry.
We have it. We see the slide. Yes, but we were at the 23 slides. Slide number 23. So we have to go. You have to move back to slides.
All right. So now which? So this one I did already, right?
Yep, almost finished. Yeah, this one is
almost
the last
finished.
one. Yeah.
Okay, so this one finished.
Yep. Okay, move.
All right. Okay. All right. So agriculture can also be impacted if native honeybee population decline as a result of pesticide. In Hanyuan province in China, sorry for the pronunciation, heavy use of pesticides resulted in a sharp decline of native honeybees population and beekeepers refusing to land their hives for pollination services. As a result, fruit trees had to be pollinated by hands. Some people are exploring options to secure pollination in heavily contaminated with pesticide environment. And there are at least two options. One is with pollinating with drones, also called robot bees, or they are also exploring the possibility to pollinate crops with genetically modified bees resistant to pesticide, also called frankenbees. So these new technologies may contribute securing food production for us, but they may also have adverse impact for bees. First, if farmers are not concerned anymore by pesticide, the impact of pesticide on pollinators, they might be willing to use more pesticide and more insecticide. So we may end up with a higher mortality of pollinators. And also, these new technologies will never replace native honeybees for the pollination of natural ecosystems. So let's be a little bit positive now after all these disasters. So what can be done to reduce or to cope with pesticide or to reduce the impact of pesticide on bees? So the first idea is to apply pesticide only when it's really needed. And to know, we should, the way to know is to monitor and assess the pest population in order to know when and how to control. This, I guess, will require a lot of education, information, and awareness raising, information and education. Also, when a pesticide is needed, as long as possible, we should avoid using bee toxic pesticide, so pesticide with a lethal dose 50 lower than 11 microgram per bee during the bloom. If we need to use a bee toxic pesticide or to blooming crop, we still can do something. We need to apply the pesticide aside from the main activity period of the pollinators. So you can see here on the graph, this is extracted from work from Dr. Cervencia from the Philippines on mango orchids. This is very informative. It shows the pollinator activity during the day on the mango flowers. And it's very clear that the main pollinator activity is in the early morning. So from basically, let's say 7 a.m. to 10, 11 a.m. So that's really the time when we should not apply the insecticide, the bee toxic pesticide. We still have plenty of time during the day later to apply the insecticide. Also, as much as possible, we should avoid insecticide with a long extended residual toxicity. And lastly, it will be wise to consider banning systemic insecticide. I'm not fully clear about the situation in Europe, but I think at least some systemic insecticide are banned in Europe. And maybe they're not, I don't know how much harmful they are for human, but I think you understood after this presentation how harmful they can be to bees. Okay, so my presentation is finished. I apologize for the small issues. My connection is not so good. So if there are, I will be happy to answer questions, but if there are some technical questions related to pesticide, I think we are lucky today to have an expert from Biothai who will be, I think we're willing to help. Okay, thank you very much.
So right now it's the Q&A session. So anybody has a question, please feel free to put your question in the chat box, and then I will read the question and Mr. Eric will answer. So the first question is, won't systemic insecticides still be harmful to bees even if they are sprayed in the evening?
Yes, of course. Yes, sure. Yeah, because their half-life is very long. Yes.
So the half-life is very long.
It's long. Yes.
I would like to know, like, how long, like how many days or how many months?
So if you remember the slide with the table, it was for fipronil, which is one of the systemic insecticide. It is 4 months, so it's very long. So actually, this, but they will decrease. They will decrease. Actually, yeah, they will decrease. Yeah, and they might be washed up by rain as well. But once they are in the soil, they will be absorbed by the plant. So this is, I think, this pesticide should be banned from a pollinator perspective.
So far as from my knowledge, every practicing that I've observed in this country is really contradict to what Eric suggested. Mainly people spray in the morning, early morning before 10. And we use kind of cocktail. And I'm not sure that maybe Prokchon could answer some question. I have a lot of questions, and I very much appreciate and thank you to Eric to present this. And it's really, I feel that this is horror. It's like a horror movie. Maybe Prokchon could add more that, do we have in place the information that what pesticides, insecticides that we use that have LD50 less than 11 microgram? Do we have that kind of information to know that which insecticide that should not apply in order to have less effective bees? If we really want to practice that according to suggestion. Or another thing that I would like to someone to add, maybe anyone here, that how many of neonicotinoids that applies in this country? I mean, widely used or what? Prokchon อยู่ไหมคะ or Eric
เป็นภาษาไทย
Sorry,
ได้
could you
ภาษาไทยได้เลยค่ะ
questions?
So one thing is, if we really want to avoid using insecticides that harmful to bees colonies, so we need to have information like LD50 that less than 11 micrograms, right?
Yes.
So we have such information that what insecticide,
we can,
what insecticide, and
we
maybe in practicing, maybe Prokchon could answer that. Do we have that information in place that we could come up with? Okay, we suggest that to avoid impact to bees. And also, what is neonicotinoid widely used in Thailand or in Southeast Asia? do we use a lot of that neonicotinoid?
I think in Cambodia, I thought, if I remember, in 2019, there were 38 systemic insecticide registered in Cambodia. I think, that's what I remember at the time I was doing my research. They are even, and I heard in Thailand, they use a lot on cassava. And cassava can be, cassava is also a good plant, not so good, but it's, bees can collect extrafloral nectar from cassava. And so they can also be impacted.
Okay. There's a lot of questions in the chats. I can't read it all, but maybe Nan would like to add something and then we will go to the question from chats.
คือแนนกำลังคิดว่าจะตอบอะไรดีค่ะมันคำถามมันค่อนข้างซ้อนกันค่อนข้างเยอะนะคะอันที่หนึ่งเนี่ยคำว่า systemic pesticide มันไม่ได้หมายถึงแค่ neonicotinoid คือถ้าเราไปดูในสิ่งที่เราตรวจพบจากการตกค้างของ pesticide ในผักผลไม้เนี่ยเกิน 60% ของชนิดคือเราเจอทั้งหมด159ชนิดใช่ไหมคะประมาณ100ชนิดเนี่ยเป็น systemic pesticide นั่นอันที่1อันที่2 neonicotinoid ในประเทศไทยมีการใช้เพิ่มขึ้นเรื่อยๆแต่ว่าแนนไม่ได้ดูสถิติมานะคะเหมือนสัปดาห์ที่แล้วที่เราทำเรื่องซีรีส์ทุเรียนเนี่ยเราก็พบว่ามีการใช้ neonicotinoid ในสวนทุเรียนด้วยเนาะเพราะฉะนั้นการใช้ neonicotinoid เนี่ยมันเพิ่มมากขึ้นเรื่อยๆค่ะอันที่3ต่อให้เรารู้ค่า LD50 ของสารแต่ละตัวที่จะเป็นพิษกับผึ้งแต่ว่าเกษตรกรเนี่ยเขาไม่ได้สนใจเรื่องนั้นนี่ค่ะในเมื่อสิ่งที่เขาต้องการคือเขาต้องการกำจัดแมลงศัตรูพืชซึ่งไม่ใช่ผึ้งเป็นเพียงแค่สิ่งมีชีวิตนอกเป้าหมายที่ได้รับผลกระทบเพราะฉะนั้นสิ่งที่เรากำลังคุยกับสิ่งที่มันเกิดขึ้นจริงในสนามเนี่ยมันอาจจะสวนทางกัน
ขอบคุณครับ thank you. So we go to the question in chat. There's some from Spencer. Would you like to say it or?
I'll read the questions out.
Yep.
So Spencer's asking that pesticides affect the bee's ability to navigate back to the hive. So more than just can it also affect this ability. Do you know anything about this, Eric?
Yes, I also read about this. Yes, I don't know the detail, but I think yes, many pesticide, let's say in general, will affect the brain of the bees. So yes, he is correct. It's correct, Spencer. Yeah, I didn't want to go in too many details in the presentation, but yes, that's one way it impacts the bees. So you are correct.
So there's another question from Walid.
Walid's asking that he knows it's important to protect bees at all costs, but he wants to know your opinion on why that is and what impacts bees have on human lives and the ecosystem.
Oh, that's a very good question. Well,
and
yes,
how
bees are important. Yeah. Maybe yes. I would say bees are important, but not only bees. I mean, let's say another way: domestic bees, because the main focus has been and is still on domestic bees. Domestic bees are important, but not only domestic bees. Native bees are also very important, but further than this, pollinators are important. So, and they are important for many things. Also, of course, for crops pollination. And I see a question in the chat box that not all the food we eat is pollinated by bees. Of course not, and neither by insect, but a lot. And even though, just forget about our food, we are also reliant on the conservation of natural ecosystem. We are not, most of us are not aware of this, but we need stable natural ecosystem. If the forest collapse, we will collapse also. And native pollinators are highly important for the pollination of forests. I just take this opportunity to mention something. Last year, yes, 1 year ago, I conducted a bee assessment in the Tonle Sap by the Biosphere Reserve, UNESCO Biosphere Reserve in Cambodia. And I found something that I think it's a part of the answer regarding the value of bees further than just pollination for direct pollination, direct impact on food. The Tonle Sap ecosystem is mainly flooded forest. And this flooded forest is extremely important for feeding and breeding of fish. The Mekong fish, because the Mekong fish migrates and come to the Tonle Sap to breed and feed. And fish is the main source of protein for Cambodians. It's 70% of the proteins are from fish. And I think in Thailand, it might be a lot as well. And so this flooded forest is crucial for the survival of the fish in the lower Mekong basin. And the survival, the regeneration and the survival of this flooded forest is reliant on pollination by insect. I mean, partly reliant on pollination by insect. I will not go into too many details, but because of the specific ecosystem, many pollinators might be excluded by the flooded regime of the Tonle Sap. In such case, migratory bee species are even more important. So I think there's still a lot of things we don't know, but yes, I'm convinced that they are important. But not only bees, for sure, not only bees.
The next question is from Rebecca. So they're asking if there's a way we can tell which plant crops are dependent on bee pollination, because it's important for people to have a better understanding of what the importance, but the public knowledge is quite low still. So like, is there a way we can tell which crops rely on bee pollination?
Yes, it's pretty well documented. And it's very simple to find this information. On Wikipedia, you have a page which is like a summary. And for many vegetables, many crops, you will know to what percentage they are reliant on insect pollination or other pollinators, and which bees and so on. It's certainly not perfect, but I think it gives good information. I set up like a kind of summary for Cambodia. I'm happy to share it.
Thank you. And also next to that point, so is there a way or the methodology that we could estimate the value that bees or pollinators has functioned for food production?
I think, yes, it has been done. I have figures, I think, from Vietnam. I found some information from Vietnam. Once again, I'm happy to share. Yes, but yeah, I will share what I have. Yeah, I guess it's quite complicated. So yeah, I have figures. I will share.
Okay, and next question is, how do you recognize bee produce has been contaminated by insecticides and how to avoid it?
The bee product. I think maybe that there are two simple ways you give to your bees, and if the bees die, you will know. No, sorry, it's not funny. Another way, it's not easy. I think to find pesticides on food or on anything is complicated. You need to send to the lab, and I think it's complicated and I guess expensive as well.
And this is from Dr. Lisa. Would you like to also speak yourself, Dr. A?
Sure. I guess it was more of just a comment that I am assuming that the limit of 11 micrograms per bee was determined based on data from Apis mellifera. And I'm assuming that different bee species have different limits. So what is safe for mellifera might not be safe for other bee species, especially smaller ones like stingless bees. And I saw that Dr. Natapot just answered that a lot of work has been carried out in neotropical species, and that yes, smaller species such as stingless bees do have a much lower limit than what is stated for Apis mellifera. So I'm not sure if Eric has anything that he would like to add to that answer, but and also if Dr. Natapot has any papers on this topic, I would be interested in them if you know of any references to point me towards.
Great. Dr. Natapot, would you like to add more?
Oh, yes, there's quite a lot of studies in the neotropics on stingless bees, and one of it is the studies of the LD50s effects on stingless bee population, because as you know, stingless bees in the neotropics are part of the major incomes for the indigenous people. So in recent year, I think in the past 10 years, there's quite a number of literature showing what's the LD50 for different types of or different species of stingless bees. And also they do a lot of tests, insecticide tests based on oral input, based on exposure to insecticide through airs, and a lot of field studies. So there's quite a number of data about these small bees and how they got affected by the insecticide they used back in Central and South. But I can provide some of the references, but it's quite pretty easy if you go down in the internet. It's already, a lot of it's where they are there.
I think we would like to also focus on the impact of I saw Spencer also mentioned that we would like to learn more. Maybe this is a research gap to understand how serious pesticides are impacting our ecosystem and food production, as the bees remain a very important pollinators in agriculture system, and also how it's affect to the bee produce honey kind of thing. So we still don't know very much. I think Dr. A and also Dr. Natapot, maybe you know more about how it's impact the using the insecticide or systemic pesticide in bees and bee colonies, and then impact to the function of pollinators of bee on food crops. Or anyone would add information about this if we have, or kind of research review, so we could go there.
I was just gonna mention that several of us within APIA are interested in studying the effects of pesticides on pollinators in Thailand, and we've already started trying to collect some preliminary data on guava orchards. So comparing pollinator communities in organic farms versus conventional farms that use chemical pesticides. So we don't have any data yet because we've only just started looking into this, but if anyone is interested in collaborating or has any information, then that would be really good.
That's great. Good news. Has anyone done about rice production? I saw rice in the picture of Eric, that also bees also doing nectars.
Pollen of rice.
Yeah, pollen of
Just
rice.
pollen, yes.
All right. That's from first. Any question, any comments?
Maybe if I can add something.
Yep.
Yes, there was something, a very interesting point raised by, sorry, I forgot the name, related to the difficulty to convince farmers to care about bees. They just care about protecting their crops against like pests. One way I found interesting is through small-scale beekeeping. Beekeepers, once people start beekeeping, they start to get interested in, they start to be aware, to become aware of the impact of pesticide. And I could witness this in several locations. First in Laos, there is a very big association, Lao Beekeeper Association working with APIA. Now there are about maybe more than 1,000 village beekeepers. And they could, at a certain time, some industrial farmers started to use a lot of pesticide in their villages. And the beekeepers were strong enough to convince them to stop. And just a recent example in Cambodia was introducing small-scale beekeeping with APIA to villages. And one of the farmer, a lady, she was applying pesticide on her vegetables. And the very first day, she lost one colony. The next week, she stopped using pesticide because she understood.
Mm-hmm. Okay. Is anyone could read Lao? I'm not sure. That's from Chanso.
I use the Google Translate in like this.
Okay, and could you please read it to Eric? That's question from sister from Lao.
Okay. Between any herbicide and any insecticide has a serious effect on bees because in Laos we use more herbicide, and she said that. I think it's disgusting, not that question.
I think the question is which one is more dangerous, more toxic to bees. And yes, usually insecticide are more dangerous to bees than our herbicide. But still, herbicide can have impact on bees as well.
So insecticides more impact than herbicides.
Yes, sure.
Okay, any question for any question?
Michael, do you have anything to add?
No, I think it's good. I mean, I want to let everybody know that, I mean, thank Dr. Natapot for already joining this session. And for our next session next month, we are welcoming him to speak on the forgotten Thai pollinators, the solitary bees responsible for the future of Thailand's terrestrial ecosystem. So I think we've had, not that if there's more questions to this, but I think that we never had the chance yet to really learn about non-honey producing bees. So that I think should be quite interesting, and also another really critical pollinator, maybe even more important than honeybees. I'm not sure. We'll learn more. So that's, I'm very happy that we'll have that next month and we can send information out.
Okay.
And again, I want to share the link. If you guys who want to be a part of the API group, Facebook, you can go and add be a part of this group via the link in the chat box. And if there is no question anymore, I would like to close the session. Is that okay? For anyone who want to share your contact for the creating more pollinator network, please feel free to type in the chat box as well. Okay, so if there is no more question, I would close the session right now. It's okay? Okay. Thank you for everyone to join the fifth webinar of APIA group. And thank you, Eric and Kingon for hosting this webinar, and thank you, Eric, for being the great speaker for the APIA. Yes.
Thank you very much.
Everyone. Thank you.
Thank you very much. It's really
Thank you very much.
enlightening.
Yeah. If anyone want to share more, feel free, but if not, I will close the meeting right now. Okay.
And I think, just Sue, I think the last time you might make the recording available on WWF website later.
Yeah. Next, maybe next week, we will share this video for on the YouTube channel, WWF Thailand. So you can check it out, and I'll share the link in the APIA Facebook group again. So please come and join us and follow our Facebook group.